channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry class, and this is your electrochemistry that what we have to discuss here. In this that we had this is of class 12 chemistry that we are dealing with NCERT solutions, yeah. And in the same cases that we had done unit 1, unit 2, and that we had started with unit 3, which is your electrochemistry, and this is your class 7. Before that, as I told you, unit 1 we had completed, unit 2 we had completed, and 3 we had started, and hopefully in the next coming classes we will end up with soon as well. Lastly, we had done a numerical. Now we'll go ahead with the starting with a new topic, which is your, and that is the on the basis that we have is your equilibrium constant from Nast equation. Equilibrium constant from Nast equation. So among in this that equilibrium constant from that Nast equation that we have to talk about it, and if the circuit in the Daniell cell that it is closed, then we wrote then that of the reaction that we talk about it, and the reaction which we have as follows is your ZnS plus Cu2 plus that is in aqueous, it gives Zn2 plus aqueous plus Cu solid here. So that takes that takes place as a time passes, and the concentration of Zn that is 2 plus here, that keeps on increasing, while the concentration of the Cu2 plus that we have here, this will keeps decreasing. At the same time, the voltage of the cell as the read on the voltmeter that keeps on decreasing here, and for that same cases after some time we shall note that there are the change in the concentrations of Cu2 plus and Zn2 plus as well ions, and at the same time, and a voltmeter gives a 0 reading for this, and this indicates that the equilibrium has been attained. And in this situation, the Nast equation that may be written in the form of as that we will go ahead, which is your E cell equals to 0, which is cell equals to 2.303 RT upon 2F log Zn2 plus upon that is Cu2 plus that we have, or we can say that E cell equals to 2.303 RT upon 2F log Zn2 plus upon that is your Cu2 plus that we have. So on the same cases that has been represented, but at equilibrium Zn2 plus upon Cu2 plus is equals to Kc for reaction, and for the same cases and at T equals to 298 K, the above equation can be written in the form of, which is E cell equals to 0.059 upon by 2 log Kc equals to 1.1 volt. So log Kc equals to 1.1 volt into 2 upon 0.059 volt, and which is equals to 37.2 288. Kc equals to 2 into 10 to the power 37 at 298 Kelvin. So in general, E cell equals to 2.303 RT upon NF log Kc that we have here. On the same cases here for this, and that is that gives a relationship between the equation constant of the reaction and the standard potential of the cell in which that the reaction take place. Thus equilibrium constant of the reaction difficult to measure, otherwise that can be calculated from the corresponding E cells values of the cell as well. Now we will be going ahead with another one that what we have to talk about it, and on the same cases the question that we deal with it. The question for that we have is calculate the equilibrium constant of the reaction which is copper plus 2 Ag plus, which is in aqueous, is Cu2 plus aqueous plus 2 Ag, that is solid here. And for that we have E cell equals to 0.46 volt. For that solution we have E cell equals to 0.059 volt upon 2 log Kc equals to 0.46 volt, or log Kc equals to 0.46 volt into 2 upon 0.059, which is equals to 15.6, where Kc equals to 3.92 into 10 to the power 15 that we have. Now this is a numerical, that is an important one as well, that is we can say that the second question that we are dealing with the solution here. After that we talk about the another topic that we have to discuss here to be as follows. So where we go ahead with another topic, and that what we have to discuss here, and that the another topic we have, and with reference towards that is electrochemical cell and a Gibbs energy of a reaction. Electrochemical cell and Gibbs energy of the reaction that we have to talk about it. So on to the same contrary, if I'm going ahead, so here for that that electrical work done in 1 second is equals to the electrical potential that multiplied by the total charge that passed. If we want to obtain the maximum that would from the galvanic cell, then charge has to be passed reversibly. Reversible work done by the galvanic cell is equals to decrease of its Gibbs energy, and therefore if the EMF of the cell is E and NF is the amount of the charge passed, and the delta R of G is the Gibbs energy in the reaction, then we can written as R of G equals to minus NF E cell. And it may be remembered that E cell is an intensive parameter, but is an extensive thermodynamic property, and the value that depends upon that. Thus if you write the reaction like in the form of Zn S plus Cu2 plus aqueous is Zn2 plus aqueous plus Cu solid here. For that we have here is your, that is delta R of G equals to minus 2Fe, and that is cell here. So but we can we write the equation here that we have as follows. So with the same cases that we have on the same that delta R of G that we had written here, that is of minus 2Fe cells, in but we can write the reaction that we have is in the another way is your 2Zn S, that is in solid, plus Cu2 plus, and that is sorry 2 Cu2 plus, and that we have in the form of aqueous gives 2Zn2 plus aqueous plus 2 copper, that is in solid. So where delta R of G equals to minus 4Fe, that is cell. So if the concentration of all the reacting species is unity, then E cell equals to E cell, and that is, and we have here that has been representing the delta R of G equals to minus NF E cell, and thus from the measurement of E that cell we can obtain the important thermodynamics quantity in delta R of G, that standard Gibbs energy of the reaction from the latter, and from the latter we can calculate the equilibrium constant by the that equation that we have here, and this is the equation that we are finding out the standard condition. And this is another one, which is delta R of G equals to minus RT log K, and this is for equilibrium constant. Now we'll do it another question here in terms of it. That is the third question of the session. The question is, the standard electrode potential for the Daniell cell is 1.1 volt. Calculate the standard Gibbs energy for the reaction, and that we have the reaction as well. The standard electrode potential for Daniell cell is 1.1 volt. Calculate the standard Gibbs energy for the reaction that we have plus Cu2 plus aqueous gives Zn2 plus aqueous plus Cu as here. For that we have to do it, and that is the solution we have as follows. Delta R of G is equals to minus NF E cell. So where N is the above equation is 2, F equals to 96487 C mole inverse, and E cell equals to 1.1 volt. Therefore delta R of G equals to minus 2 into 1.1 volt into 96487 C mole inverse equals to minus 21227 joule mole inverse equals to minus 212.27 kilojoule mole inverse here. There are many more questions that to be solved out here on the concept that I will be telling you. For the solution you have to solve it out, and those questions were First is to calculate the potential of hydrogen electrode in contact with the solution whose pH is 10 here. And for the same case, another question is to calculate the EMF of the cell in which the following reaction takes place, that is Ni solid A plus 2 Ag plus, that is your 0.002 mole, and that will be, that gives the Ni2 plus, which is 0.160 m, and 2 Ag that is in the form of solid. So given that E cell is your 1.05 volt, and that what we have to solve it out as well. The other question we have is the sixth question that I had given you for the solution for your sake, that you have to solve it out. That the cell in which the following reactions is 2Fe2 plus 3 plus aqueous plus 2I minus aqueous gives 2Fe2 plus aqueous plus I2 solid, that has E cell is your 0.236 volt at 298 Kelvin, and calculate the standard Gibbs energy and the equilibrium constant of the cell reaction, that we have to find out. Now we'll go ahead for the other question that we have to talk about it, and that is another topic we have to go ahead, which is the conductance of electrolytic solution that we have to discuss here. Let's go ahead further with that. So that we have here is your conductance of electrolytic solution that we have. So in this, that it is necessary to define a few terms before we consider the subject conductance of electricity through the electrolytic solution. So the electrical resistance is represented by the symbol R, and it is measured in the ohm, and which is terms as SI unit, the SI base unit is equals to the kg meter square and S3 A square, and that is, it can be measured with the help of a that is Wheatstone bridge with when you are familiar from your study of the physics, and that electrical resistance of any body is directly proportional to its length, and as well as on the same case that is denoted, the length has been denoted by L here and respectively, and inversely proportional to the area of the cross section area, that is we have A, and which we have as a formula that we have to represent it is to be as follows: R 1 upon A, or R equals to L upon A here. The constant of the proportionality, we have, this is a Greek rho, and it is called resistivity, specific resistivity, and that is known as specific resistance. And the SI unit of the ohm, this we have is your ohm meter, and in the same case ohm centimeter, and is also used, and in the ohm centimeter it is, and it is quite often its sum multiple is quite often that we have to use it. Quite often it's a sum multiple ohm centimeter is also used, and IUPAC recommends the use of the term resistivity over the specific resistance, and hence in the rest of the book we shall use the term resistivity, but physically that the resistivity for a substance of its resistance, then when it is 1 meter long and its area of the cross section is 1 meter square, it can be written as in the form of, which is 1 ohm equals to 1 ohm meter equals to 100 ohm centimeter, or 1 ohm centimeter equals to 0.01 ohm meter. And the inverse of the resistance, where R is the conductance, and here, and resistance is R and C is the conductance, and we can written the equation in the form of, which is G equals to 1 upon R equals to A upon L equals to K A upon L, that we have. So here in this, that the SI unit for the conductance is Siemens. Conductance SI unit is Siemens, So that is represented by the symbol S here, and N is equals to the ohm inverse, and that also known as MO as well, and that is ohm inverse, the symbol that has been representing. The inverse of the resistivity is called the conductivity, which is your specific conductance, that is represented by the K Greek, that is known as the K Greek has been known as the kappa. And the IUPAC has been recommend the use of the term conductivity over the specific conductance, and hence we shall term the conductivity in the rest of the book. The SI unit of the conductance that are as meter inverse, but quite often K is expressed as centimeter inverse, and conductivity of the material is S meter inverse. Is the conductance when it is 1 meter long, and it is area of cross section is 1 meter square, and it may be noted that 1 sm, I just write it down for you, 1 sm is 1 s centimeter is equals to, which is equals to here 100 s meter inverse, that we have to talk about it. And to the same contrary, we go ahead, and that even though we have to talk about it, so on the same that is for the table, that the value of the conductivities of the some material that we talk about it. So where we have a materials and they have a conductivity on that, so that we go ahead, and that even though discussed about it, so yes, we'll go ahead here. Material, conductivity, material, conductivity. So on talk of about the conductors, materials and and the conductivity, we'll talk about the differences like conductance and insulator. We'll talk about an aqueous solution, and then we semiconductors. We'll talk about the conductivity for each. So we'll start with the conductors. So the first conductor we'll talk about is the sodium. For sodium, that the conductivity we have, I just partitioned all. So for the conductance, the first is sodium, that is 2.1 into 10 to the power 3. Then we have copper, that is your 5.9 into 10 to the power 3. Then we have another one is your silver, that is 6.2 into 10 to the power 3. We have gold, 4.5 into 10 to the power 3. Then iron, 1.0 into 10 to the power 3. Then graphite, 1.2 into 10 to the power 1. Now we'll talk about for the insulator as well, so that we have the two insulators. For the insulator we have, and that the first insulator is your glass. For the glass, that is your 1.0 into 10 to the power minus 16. The second insulator is your Teflon, 1.0 into 10 to the power minus 18. Now we'll talk about the material here. Now the material we will talk about the aqueous solution. The aqueous solution, the material we have is your pure water. In terms of pure water, if I am going ahead, and that is the conductivity we have is your 3.5 into 10 to the power minus 5, 0.1 m SCl, which is 3.91, 0.01 m KCl, which is 0.40, 0.01 m NaCl, which is 0.12, 0.1 m HAC, which is your acetic acid. This is acetic acid, that is 0.047, 0.01 mHAC, that is acetic acid, 0.016. I will talk about the semiconductors as well, that we have to discuss here. Semiconductors. On that we have a two semiconductor, silicon and germanium. For silicon we have, it is your 1.5 into 10 to the power minus 2. Copper oxide as well, that is your 1 into 10 to the power minus 7. And germanium that we have is your 2.0. So that is we have values of conductivity of the material at 298.15 Kelvin, and that we have to discuss here. Now we will be going in the same cases that it can be seen from this that the magnitude of the conductivity where that varies a great deal on depends upon the nature of the material, and it also depends on the temperature and pressure at which the measurements are made, and materials are classified into the conductor, insulators and semiconductor depending on the magnitude of their conductivity. Their metals and their alloys have their very large conductivity and are known as conductors. Certain non-metal like carbon black, graphite and some organic polymers are also electronically conducting here. On the same cases with the say that the substance like glass, ceramics etc having very low conductivity and that are known as insulator. Substance like silicon, doped silicon and gallium arsenic having conductivity between the conductors and insulators that are called semiconductors and are important electronic material, and certain material called superconductors by definition have zero resistivity or the infinite conductivity, and earlier only metals have their alloys at very low temperatures like 0 to 15 Kelvin were that known to behave as superconductor, but nowadays a number of ceramic materials and mixed oxides are also known to show the superconductivity at temperature at high of 150 Kelvin as well. Electrical conductance through metals is called metallic, and electronic conductance is due to the movement of the electrons. The electronic conductance depends upon the three categorization, where that is the nature of the structures, the nature and the structures of the material, the number of the valence electron per atom, and temperature that it decreases with increase of the temperature as well. On the same cases as the electrons enter at one end and go out through the other end, and that the compositions of the metallic conductance remains unchanged. The mechanism here that we have to talk about it, that the mechanism of the conductance through the semiconductors is more complex. We already know that we had discussed in the last class here, that is of unit class 7th, that we had discussed about unit 7 here. Class 11th we had discussed the unit 7, that is that even very pure water has a small amounts of hydrogen and hydroxyl ion, which is near about 10 to the power minus 7 m, and which lend at very low conductivity, which is 3.5 into 10 to the power 5 Siemens meter inverse as well. And when electrolysis are dissolved in water, they furnish their own ions in the solution, and hence its conductivity also increases. The conductance of electricity by ions present in the solution is called electrolytic or ionic conductance, and the conductivity of the electrolytic ionic solution depends on the first that depends on the nature of the electrolyte added, and the second that the size of the ions produced and their solvation, third the nature of the solvent and its viscosity, the fourth the concentration of the electrolytic, and the fifth we talk about it, which we have here is your that is the temperatures. It increases with increase of the temperature, and where the passage of the direct current through ionic solution over a prolonged period that can lead to change in its composition due to the electrochemical reactions here. So on the same cases we will be going ahead further, and even though that what we have to talk about it, which is all about your the measurements that of the conductivity of the ionic solution. We'll talk about it, and that we have to go ahead here. measurement of the conductivity of ionic solution. On the same contrary for this, and that is we know that the accurate measurement of an unknown resistance that can be performed on a Wheatstone bridge. And however, for measuring the resistance of an ionic solution, we face two problems. Firstly, the passing direct current, which is your DC, changes to the composition of the solution, and secondly, a solution that cannot be connected to a bridge like a metallic wire or the other solid conductor. The first difficulty is resolved by using an alternating current, which is AC source of power, and the second problem is solved by using the specially designed vessels that is your called conductivity cells here. On the same cases, it is available in several designs, and two simple ones are shown here. So on the same case, that what we have to discuss here, and on respect towards it, where the conducting wire has been joined with a platinum electrode, and that is a platinized electrode as well. So basically it's consist of the two platinum electrode coated with platinum black, finally divided metallic PTL deposited in the electrode electrochemically, and these have the areas of the cross sections equals to A and are separated at a distance T L, and that is therefore the solution confined between these electrode in the column of length L and the area of cross section A, that the resistance of such a column of solution is then given by the equation that can be represented in the form of which we have equals to L upon A equals to L upon K A here. So on the same contrary, we'll go ahead, and that what we have to talk about it, where that the quantity which has been, that is your L by A, is called your the cell constant, that denoted by the symbols, and it is depends on the distance between the electrode and their cross sections, and has dimensions of length inverse, and that can be calculated here. And if we know that LNA, that measurement of LNA is not only that inconventional but also unreliable, and the cell constant is usually determined by the measure the distance of the cell containing the solution whose conductance already known. For this purpose, we generally use KCl solution, while conductivity is known accurately at various concentration and at a different temperature. We'll talk about it, and that is on the same cases here, and that we have to go ahead. So here on the same way we'll talk about it, and in the same case that we'll talk about the conductivity that is denoted by, and we have as follows. So quantity L by A is called a cell constant, that is denoted by the symbol, and that is your the G here, and it depends on the distance that we have. It depends on the distance between the electrode and their cross sections, and has the dimensions of length, and that can be calculated if we know L and A. Measurement of LNA is not only incoming the inconvenient, that the resistance of the cell containing a solution and whose conductance conduct already known. For this purpose, we generally use KCl solution, that conductivity is known accurately at a various concentration and different temperatures, and that the cell constant, which is your G abstract, is then given as, and that has been representing in the form of which we have G abstract equals to L upon A equals to RK here. So that the conductivity and the molar conductivity of the KCl solution at 298.15 Kelvin, and the concentration, molarity, and conductivity and molar conductivity that we talk about it. Let's go ahead. Concentration, molarity, conductivity, and molar conductivity. Okay, so that we have as follows, which is your mole inverse, mole meter inverse cube, that we have as your 1.000. This is 1000. This is 0.100. This is 100.0. 0.010. This is your 10.00. The conductivity for that we have here, which is also being divided. This is S centimeter inverse, as meter inverse, so that is 0.1113, 11.13. This is 0.0129. This is 1.29. This is 0.00141. This is 0.141. For the molar conductivity, talk about as centimeter square mole inverse and as meter square and mole inverse. This is your 111.3, 129.0, 141.0 here. This is that what we have to go ahead, and that is your 101.3 into 10 to the power minus 4. This is 129.0 into 10 to the power 4 minus 4, and this is 141.0 into 10 to the power minus 4. So here that is that has been representing. Once the cell's constant is determined, we can use it for the measuring the resistance or the conductivity of any solution, and the setup for the measurement of the resistance we have. It consists of two resistance, R3 and R4, and a variety of the resistance that has been the R3 and the Whitestone bridge fed up to the oscillators O, and a source of AC power of the audio frequency range 550 to 5000 cycles per second, and P is a suitable detector of the headphones that is used with the other electronic devices, and that the bridge is balanced when no current passes through the detectors and these conditions as well. So unknown resistance, we'll talk about it. So, and for that we have, so unknown resistance is equals to R2 equals to R1 R4 upon R3, and these days in expensive the conductance meters and the available, which can be directly read the conductance or the resistance of the solution, the conductivity cell. Once the cell constants and the resistance of the solution in the earth called determined by the conductivity of the solution, that is to be given as in the form of the equation, which can be written in the form of, which is K equals to cell constant upon R equals to G abstract upon R. So on the same case, the conductivity of the solution of the different electrolyte is the same as solvent, and at the given temperature differ due to the charge and the size of the ions in which they dissociate, the concentrations of ions, or ease with which the ions move under the potential gradient, and it therefore becomes necessary to define a cycle physically that we have, and physically the more meaningful quantity called the molar conductivity, denoted by the symbol A of M, and that the Greek is your lambda that has been representing it. It is conductivity of the solution by the equation that that we have, and which is the molar conductivity, we talk about it, and many more things that we have to representing as well. So that will discuss in the next coming class, that we have to go ahead, and on the basis we have to do it the numerical part as well, that on the same cases and on the same topic as well. So that we'll discuss in the next coming class with the formula as well. So here we'll end up with, we had completed the sociology, we had completed your we had started with software engineering, where we had completed unit 1, unit 2, and unit 3 we are dealing with, and sorry, unit 4 we are dealing with, unit 3 we had completed quantitative aptitude. We had covered up the arithmetical ability, where we had started with operations on numbers and LCM and SCF of numbers and decimal fractions. Simplification we are dealing with, where we had completed more than 1,000 questions there, and in the verbal reasoning we had completed the verbal reasoning, where we have completed the general mental ability in the logic reasoning, and in the non-verbal reasoning we had started with, and that we had completed more than 1,000 questions on series, 500 questions on analogy, and 500, near about 500 questions on classification as well. After that we will start with analytical reasoning as well, that the fourth topic of the non-verbal reasoning. In terms of the other subjects we talk about it, and that in the terms of the chemistry that we are dealing with, and here we had completed unit 1, unit 2, and unit 3, which we had started with, and hopefully in the next coming classes we will end up with as well. In unit 1, if I am going ahead, that is the name of the unit is just the solid state. In solid state we had completed the general characteristics of the solid state, amorphous and crystalline solid, classification of crystalline solid, crystal lattice and unit cell, number of atoms in the unit cell, closed pack structure, packing efficiency, calculation involving the unit cell dimension, imperfection in solid, electrical properties and magnetic properties as well. In second unit, that is the solution that we have to talk about it, that we had done types of solution, expressing the concentration of solution, solubility, vapor pressures of liquid solutions, ideal and non-ideal solution, colligative property and determinations of molar masses, abnormal molar masses as well. In the third unit, which we had started with, where we have to cover up, that is your electrochemistry, where we had done electrochemical cells, galvanic cells, Nernst equation, conductance of electrolytic solution, electrolytic cells and electrolyte and batteries, fuel cells and corrosion. Then after that we'll start with discussing about unit 4, where we have to discuss the chemical kinetics, which is your rate of chemical equation, reactions and factors influencing the rate of reaction, integrated rate equation, pseudo first order reaction, temperature dependence on the rate of the equation, collision theory of the chemical reaction as well. Then after that we'll start discussing about unit 5, which is the name of the unit is the surface chemistry, which is adsorption, catalyst, colloids, classification of colloids, emulsions, colloids around rust as well. Unit 6 is your general principles and processes of isolations of element, that is occurrence of metals, concentrations of ores, extractions of crude oils from the concentrated ore, thermodynamic principle of metallurgy, electrochemical principles of metallurgy, oxidation, reduction, refining, uses of aluminium, copper, zinc and iron as well. After that, in unit 7th we have to cover up, where we have to cover up, that is the p block element, that is your group 15 element, dinitrogen ammonium oxide of the nitrogen, nitric acid, phosphorus, allotropic forms, phosphine, phosphorus halides, oxo halides of the phosphorus, group 16 element, that dioxygen, and simple oxides, ozone, sulfur, allotropic forms, sulfur dioxide, oxo acids of the sulfur, sulfuric acid, group 17 element, chlorine, hydrogen chloride, oxo acids of halogens, enter halogens compound, groups 18 element as well. After that, unit 8 we have the D and F block element, where positions in the periodic table, electronic configuration of the D block element, general properties of the transition elements of the D block, some important compounds of the transition element, the lanthanides, the actinides, some application of D and F block element here. The unit 9 we have to talk about the coordination compound, which is the Warner's theories of the coordination compound, definition of some important terms pertaining to the coordination compound, nomenclature of coordination compound, isomerism of coordination compound, bonding in coordination compound, bonding in metal carbonalysis, and stability of the coordination compound, importance and application of coordination compound as well. So after that we'll start discussing about the next part of this chemistry of class 12. And first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And thanks to all those subscribers, those who had subscribed our channel, and thanks for supporting us and thanks for appreciation. Thank you.